In this video, we're going to practice taking the antiderivatives of functions that have a little tiny bit of composition going on. Specifically, we're looking at the antiderivative when the inner function that we have is just linear, something like 4x or 2x, maybe something like x plus 1, something like that. For functions where the inside function is linear, what we can do is take the antiderivative of the outside, leave the inside the same, and then divide by the derivative of the inside. So let's see what we mean by that. So let's look at the antiderivative of cosine of 4x. If I want to take the antiderivative, what I'm going to do is I'm going to take the antiderivative of cosine, that's sine. I'm going to leave the inside the same, so we'll leave that as sine of 4x. But then I need to divide by the derivative of the inside. So when I do that, the derivative of the inside is just 4. So that's going to be sine of 4x over 4. And then since we're taking the antiderivative, I need to add my constant plus c. And you'll notice if you take the derivative of sine of 4x over 4, the chain rule will basically make that 4 in the denominator go away, and you will once again get back to cosine of 4x. So this ended up working out. Let's try another example. So we have g of x. I'm going to take the antiderivative of e to the 3x. The antiderivative of e to the 3x. We'll start by taking the antiderivative of the quote-unquote outside. My inner function is this 3x. So we're going to take the antiderivative of e to the x. That's still just e to the x. Leave the inside the same. And then divide by the derivative of the inside. Then we'll add our constant. This next one doesn't quite look like what we're used to, but if we notice, we can rewrite 1 over e to the 3x as e to the negative 3x. Once we do that, it's a simple matter of just applying the same rule. My outer function is once again e to the x. So I'm going to take the antiderivative of e to the x, which is still e to the x, leave the inside the same, and then divide by the derivative of the inside, which is negative 3. That will get that. Next, we have j of x equals 1 over 1 plus 2x squared. Well, what you might remember is that the derivative of arctangent is going to be 1 over 1 plus x squared. So I can think of this as my outer function is 1 over 1 plus x squared. My inner is this 2x. So when I take the derivative or the antiderivative of the outside, I'll have arctangent. That's the antiderivative of my outer 1 over 1 plus x squared function. But we'll leave the inside the same, 2x. Then we're going to divide by the antiderivative of the inside, by the derivative of the inside, that's divide by 2. Then we add our constant plus c. Now this last one will take a little bit of extra work because arctangent has a 1 right there, and this function here doesn't. If I want to get a 1 there, what I need to do is I need to multiply the numerator and denominator by 1/4. That's going to let me rewrite this as 1/4 over 1 plus x squared over 4. There's one other thing I don't quite have yet. In this, I had something in parentheses being squared, but here I have something being squared and it's being divided by another number. What I actually want to do is I want to rewrite x squared over 4. I can think of that as x squared over 2 squared, which is the same as x over 2 squared. So I'll rewrite that denominator as we'll have 1/4 over 1 plus 1 over 2, x over 2 squared. And just for good measure, I'm going to rewrite this as 1/4 on the outside times 1 over 1 plus x over 2 squared. having it like this, I note that I can combine this with kind of a constant multiple rule to be able to take my antiderivative. So for my antiderivative, I'm going to start by kind of pulling out my constant multiple of 1/4. So I pull that out, and now I'm just going to look at what's left. Well, this looks like the antiderivative of arctangent, but x has been replaced with x over 2. So take the antiderivative of the outside, that's going to be arctangent of x over 2. And then I need to divide by the derivative of the inside. So I'm dividing by 1/2. But that's a little silly. That's the same as taking 1/4 arctangent of x over 2 times 2, which will end up just being 1/2 arctangent of x over 2. And we add our constant at the end. Technically, we should have had our constant for all of these, but here we are. So that required a little bit more work, but it wasn't anything totally crazy. So hopefully that gives you an idea of some of the things you can do with antiderivatives.